Oh my gosh, we're recording. Okay, so here I am, and I'm doing the intro to my uh, Military Industrial Museum feature presentation on Nikola Tesla. So, what that entails is there's an old magazine series. It's called Electrical Experimenter, and they did a very big, I guess, emphasis on Nikola Tesla. And so what someone did, a big Tesla fan, is they grabbed all the articles that they knew of that Electrical Experimenter put together, and then also another article from another magazine, I guess, later in Tesla's life. So anyway, what I did is I took those articles and I had them run through a brand new feature at this date time, which is late March 2026. It's called Google Notebook LM Cinematic. And so it brings to life some of the concepts which are pretty dense, especially for today's audience with the short attention span. So what I'll do is I'll link in the description a link to the Internet Archive where you can download the articles and read them for yourself. But what you can do is just watch the presentations, and if you see one you like, you can actually go to the article and see what it's all about. So that was the whole point. But I just want to explain where you can go from here and enjoy yourself learning all this heavy-duty electro theory. So other than that, please subscribe and like my videos and leave a comment and stuff. I see all the comments, obviously. And yeah. Okay, well, let's get to the show. Alexa, turn off the light, please.
Got it.
You tell this is well rehearsed. All right, let's get to the show. The feature presentation on Nikola Tesla from Military Industrial Museum. Sorry, I gotta shut this off.
In the early 1900s, communication meant building massive iron lattice monuments. These colossal radio towers dominated the skyline, seemingly proving our mastery over invisible forces. Yet, one of the era's most prominent technical minds looked at these towering structures and declared them entirely obsolete. At the time, the accepted science was built on the theories of Heinrich Hertz. Hertzian theory posited that radio transmitters worked by shooting invisible, concentric ripples of energy out into the atmosphere, much like a stone dropped into a quiet pond. To the global scientific community, this atmospheric wave model was an unquestionable law of physics. The textbooks were written, the transmitters were built, and dissenting opinions were simply dismissed. But a closer look at the data revealed glaring inconsistencies. Operators constantly wrestled with localized dead zones, erratic signal ranges, and overwhelming static interference. These ground-level anomalies flatly contradicted the clean mathematical models of airborne waves. The publisher willing to point out these flaws was Hugo Gernsback, the driving force behind the widely read Electrical Experimenter magazine. He possessed a massive readership of engineers and tinkerers, and he was about to use that platform to challenge the core tenets of physics. In his January 1919 editorial titled The New Wireless, Gernsback delivered a shock to the scientific establishment. He bluntly stated that the orthodox view of wireless propagation was totally erroneous. He proposed a radically different model. Instead of radiating upward and outward through the sky, Gernsback argued that radio impulses were actually galvanic currents pulsing straight through the subterranean layers of the Earth. Any airborne waves, he insisted, were merely a weak accidental byproduct of this deep terrestrial conduction. To back up this heresy, Gernsback pointed to 3 specific, undeniable glitches in how radio systems actually performed in the real world. The first piece of physical evidence was the distance multiplier of the oceans. Radio operators knew that a transmission sent over open salt water would travel 3 to 5 times further than the exact same signal sent across dry land. If the waves were strictly traveling through the air, the surface below shouldn't matter. But since salt water is a highly efficient electrical conductor, Gernsback argued the signal was clearly hitching a ride through the physical medium of the water itself. The second anomaly, the ground wire. Radios required a thick copper wire buried in the soil. Gernsback argued shooting energy skyward while tethered to dirt made zero mechanical sense. This earth connection was the actual conduit, completing a massive subterranean loop. The practical proof was highly observable. If an operator disconnected that earth line, their transmission range instantly collapsed to pitifully small distances. These operational quirks, the boost from salt water and the absolute reliance on soil connections, formed a solid, measurable foundation for rejecting the concept of atmospheric transmission. The third and most compelling piece of evidence came directly from military testing. Leading physicists insisted that communicating with a submerged vessel by radio was physically impossible because water absorbs and blocks airborne high-frequency waves. But an American inventor named James Harris Rogers ignored the consensus. He successfully established clear, continuous radio contact with military submarines while they were operating fully 25 feet below the ocean's surface. Rogers took his experiments onto dry land, burying his receiver wires entirely underground. Not only did he pick up long-distance signals from European stations, but he found that burying the wire completely eliminated the heavy atmospheric static that frequently crippled traditional elevated antennas. Gernsback didn't invent this subterranean theory from scratch. He was using his magazine to vindicate the long-ignored work of Nikola Tesla. Tesla, the pioneering electrical engineer, had been preaching this exact model for decades. Analytical, this historical diagram shows exactly what Tesla meant. As far back as 1893, Tesla filed patents detailing a tuned oscillatory system designed specifically to drive high-tension currents through the Earth. He consistently argued that the concept of gliding airwaves was a physical fallacy. Armed with Rogers' submarine tests and Tesla's mathematical blueprints, Gernsback concluded that by 1919, the true nature of wireless technology had finally been proven by actual working military hardware. Confident in this data, Gernsback made a bold prediction for the coming decade: the total demolition of the world's towering radio antennas, replacing them with highly efficient, buried ground wire networks. A look around today shows exactly how that prediction turned out. Modern communications rely on a dense forest of skyward-facing transmitters, cellular towers, and satellites. Neither Tesla nor Gernsback could account for a massive missing variable in their equations: the ionosphere. The ionosphere is a shell of electrons and electrically charged atoms and molecules that surrounds the Earth, stretching from roughly 30 to 600 miles above the surface. This ionized shell acts like a massive planetary mirror for specific radio frequencies. This bounce effect perfectly explained the anomalies. Signals traveled further over oceans because the conductive water acted as a highly efficient lower mirror, creating a trap that allowed the airborne waves to skip across the globe, entirely bypassing solid ground conduction. History ultimately sided with the Hertzian wave traveling through the sky. Yet, looking at the localized dead zones, the static, and the submarine data available in 1919, Gernsback's earth conduction theory was a perfectly logical application of the scientific method to the physical evidence he had. This great radio heresy demonstrates how theories are built and broken. When anomalous data stacks up against a rigid consensus, the accepted models of physics are often just one invisible discovery away from complete collapse. We have all seen optical illusions. You stare at a spinning geometric shape, and suddenly it shifts direction. Your eyes haven't changed, and the screen hasn't changed, but your brain actively misinterprets the light hitting your retinas, feeding you a false version of reality. We treat these visual glitches as fun parlor tricks, but we rarely consider what happens when the exact same biological hardware is used to observe the laws of physics. Scientists are looking through the same flawed lenses as the rest of us. By 1919, Nikola Tesla was a living legend. He had already pioneered the alternating current electrical system that powered the modern world and laid the groundwork for radio transmission. He spent his life surrounded by complex engineering and invisible forces. That year, he published a sharp critique of the scientific establishment in the Electrical Experimenter magazine, titled Famous Scientific Illusions. Tesla argued that the human brain is an imperfect apparatus. Because our organs of reception are deficient and deceptive, he believed the brightest minds of his era were trapped in a collective delusion, building entire branches of physics on tricks of the mind. To prove it, he targeted 3 universally accepted scientific facts. He set out to demonstrate that what the establishment called physics was actually a series of sensory deceptions. The first target was celestial mechanics. The established scientific consensus states that the moon rotates on its own axis exactly once per orbit. This synchronous rotation is why we always see the same face of the moon from Earth. Tesla claimed this was a pure optical illusion. He argued that the moon does not spin at all. Instead, he proposed that the impression of rotation is created entirely by its successive changes of position as it moves through space. This diagram shows his mechanical analogy. A ball fixed to a wheel spoke represents the moon's orbit. Being gravitationally locked, Tesla argued its movement is purely translatory, moving along a fixed path. A rigid body locked to a central point possesses no independent rotational energy. If his logic held, humanity's entire understanding of orbital dynamics was wrong, derailed by a simple trick of perspective. He next moved from theoretical astrophysics to structural engineering, targeting Benjamin Franklin's pointed lightning rod. For over a century, architects trusted this design to safely draw electricity away from buildings during storms. Tesla analyzed the physical properties of the rod and concluded that Franklin's beloved invention was actually a severe hazard that increased the risk of a strike. The danger is ionization, turning neutral gas into conductive plasma. Franklin's sharp rod ionizes the air, creating a pathway that actively attracts lightning. To fix this, Tesla proposed a rounded, blunt-tipped conductor. Its smooth geometry repels the static electrical field, keeping the building safe. By accepting a centuries-old engineering practice without questioning the underlying physics, builders were literally putting lives at risk. Finally, Tesla attacked the emerging telecommunications industry and the work of physicist Heinrich Hertz. Hertz had established the accepted theory that radio communications travel through the air via space waves. Tesla aggressively pushed back. He argued that radiating electromagnetic waves outward into the ether was an inefficient illusion that resulted in wasted, unrecoverable energy dissipating quickly over distance. This illustration shows Tesla's alternative theory. True wireless transmission, he insisted, surges directly through the Earth's conductive interior. He illustrated this with a fluid pump on a hollow sphere. Every pulse creates a simultaneous pressure change at all points, perfectly preserving the energy. Tesla was looking at the exact same radio equipment as his contemporaries, yet he accused the entire scientific establishment of completely misinterpreting the physical reality of their own instruments. Did time and modern physics vindicate Nikola Tesla's 1919 crusade, or did his own brain deceive him? On celestial mechanics and radio, Tesla was wrong. Modern physics confirms the moon absolutely possesses rotational energy, spinning exactly once per orbit, and our entire global telecommunications network relies precisely on the airborne Hertzian waves that he so casually dismissed. But his engineering critique of the lightning rod proved highly prescient. Modern meteorological research validates his ionization theory, and blunt-tipped rods are now recognized as far more effective than Franklin's sharp points in many applications. Science is an ongoing, relentless process of testing and discarding assumptions. Tesla's legacy is not determined by his batting average on these 3 specific claims, but by his willingness to scrutinize the limits of human observation. True scientific genius requires the courage to look at a universally accepted truth, recognize the biological flaws in the person observing it, and dare to ask, is this just an illusion? When we think of Nikola Tesla, we picture a towering intellect operating on an almost supernatural level. We imagine the master of lightning sitting perfectly still while millions of volts of electricity tear through the air around him. But in January 1919, Tesla decided to explain his own life in the pages of the Electrical Experimenter magazine. The editors promised their readers a serious psychological breakdown of his methods, posing the heavy question, how does the world's greatest inventor invent? Tesla's answer didn't start with complex mathematics or alternating current. Instead, his autobiography opens with a story about a hyperactive kid grabbing an umbrella, climbing to the top of a barn, and stepping off the roof to see if he could fly. To understand how he eventually learned to control electricity, we have to look closely at these chaotic early instincts and how they shaped his approach to science. In his adult life, Tesla operated on a very specific philosophy. He believed the ultimate goal of human progress was the complete mastery of the mind over the physical world. But during his childhood, this drive to control nature wasn't a calculated academic pursuit. He described it as a raw, untrained impulse. His very first physical experiment involved local wildlife. He built a rotating motor powered entirely by live insects. This diagram illustrates exactly how his machine worked. He attached a group of June bugs to a crosspiece, relying entirely on the sheer weight and the vibrating energy of their trapped beating wings to force a central spindle to spin continuously. It sounds like a bizarre neighborhood prank, yet it was a genuine, structured attempt to extract mechanical power directly from his environment. That chaotic, bug-powered machine laid the conceptual foundation for a lifelong obsession with capturing raw energy from the natural world. The physical world, however, was only half of his reality. Inside his own head, he was dealing with a much darker struggle. He wrote openly about suffering through what he called the sheer agony of a vivid and undisciplined imagination. He experienced overwhelming hallucinations. Complex machines and entire landscapes would flash in front of his eyes, replacing the physical room around him. These intense mental projections were dangerous. The sudden disconnect from his physical surroundings disoriented him, leading to violent accidents and deep psychological distress. He quickly recognized a harsh reality. He had to find a way to consciously master these intrusive images, or he wouldn't be able to function at all. Long before he could design heavy industrial equipment, he had to engineer a strict psychological framework just to survive the weight of his own mind. Looking back on his youth, Tesla actually described this agonizing mental condition as a blessing in disguise. The sheer effort required to fight off those hallucinations taught him how to exert absolute, unyielding discipline over his thoughts. This wireframe animation illustrates his ultimate solution, a mental sandbox. He learned to consciously project and assemble complex devices, like an induction motor, which is an electric motor that uses alternating current to create a rotating magnetic field, entirely within his imagination. Because of this condition, he could set a virtual motor running in his head, leave it for weeks, and then inspect the mental image for precise marks of wear and tear. This completely eliminated his need to build early physical prototypes. This intense cognitive control is exactly what allowed him to safely visualize and perfect massive, lethal electrical grids and hydroelectric plants before a single piece of copper was ever cut. The infrastructure that powers our modern cities wasn't born in a traditional laboratory. It was rigorously tested and perfected inside the disciplined mind of a boy who first learned to harness energy by capturing a beetle. Early wireless telegraphy promised an absolute miracle, the ability to send invisible messages bridging entire oceans, connecting distant continents without a physical cable between them. But operators quickly ran into a crippling physical barrier. They called it static, a relentless, crashing wall of noise that frequently drowned out the very signals they were trying to receive. Radio engineers spent years treating this as a hardware problem. They built increasingly complex physical filters, added supplementary dials, and continuously retuned their equipment, hoping to somehow isolate the clear message from the surrounding chaos. The issue was that static was a constant barrage of natural atmospheric electricity. Every thunderstorm, every shift in weather, and every stray electrical discharge in the sky flooded the air with competing energy. By relying on the air to transmit messages, early wireless stations were forcing their delicate instruments into a direct, unavoidable battle with the chaotic energy of the sky itself. In January 1919, A highly detailed article appeared in the Electrical Experimenter magazine titled The True Wireless, offering a radical explanation for why the static problem remained unsolved. They argued that the scientific community was failing to filter out the noise because they were completely wrong about how wireless waves travel from point A to point B. He proposed a harsh ultimatum. Engineers would never be able to build a successful filter. To eliminate the noise, they had to throw out their massive sky-high antennas entirely and redesign the physical architecture of radio from scratch. That author was Nikola Tesla, and to him, the static problem was a systemic crisis that required tearing up the physics textbook and starting over. The entire radio industry of 1919 was built on the theories of physicist Heinrich Hertz. The accepted Hertzian model, the theory that invisible waves travel as radiation through the air, dictated that signals propagate much like light radiating from a bulb. This concept dictated a specific type of engineering. To catch these airborne waves, engineers constructed massive exposed metal towers that reached hundreds of feet into the sky. But towering metal structures built directly into the atmosphere inherently act as giant lightning rods. While they waited for a specific signal, they spent all day absorbing the chaos of natural atmospheric electricity. Because the desired signal and the unwanted static both travel through the exact same medium, the air, they hit the receiver intertwined. Separating them cleanly is practically impossible. Tesla viewed the Hertzian model as an architectural trap. By insisting that signals must fly through the air, engineers forced their machines to fight the very medium they relied on. Tesla countered with his own theory. True wireless energy, he argued, does not travel as weak radiation through the sky. It travels as a powerful electrical current conducted directly through the ground. This diagram illustrates Tesla's physical model of the planet. He viewed the Earth as a massive, highly conductive globe, tightly encased in a thin layer of non-conducting, insulating air. And here, this diagram titled Mode of Propagation shows the mechanics of his solution. By injecting an electrical pulse directly into the Earth, the signal travels safely and rapidly through the solid ground, entirely bypassing the static-filled air above. A receiving station located miles away wouldn't need a massive tower scraping the sky. It would simply tap into the ground and pull the pure, oscillating signal directly out of the planet's surface. By reimagining the Earth itself as the primary wire, the entire concept of atmospheric static became physically irrelevant. The noise was in the sky, the signal was in the dirt. Tesla's theory found validation when operators decided to physically rip down their towering sky-high aerials and bury their receiving wires directly in the dirt. Operators implementing systems like the Rogers underground antenna, a method of burying the receiver heavily in the soil, experienced an immediate drop in noise. The agonizing static vanished entirely, leaving only crisp, clear communication. The logic behind this success was remarkably simple. The atmospheric condition we call static requires an atmosphere. It simply does not exist beneath the surface of the ground. The success of buried antennas served as physical, operational evidence that long-distance signals were indeed traveling through the solid Earth, validating Tesla's conduction logic. Tesla's ambitions extended far beyond clearing up radio chatter. He viewed earth conduction as the foundation for his world system, a theoretical network capable of transmitting limitless global power through the ground without interference. His approach to the static problem reveals exactly how he operated. When faced with a seemingly impossible physical barrier, he didn't build a better filter. He discarded the foundational rules of the system to bypass the barrier entirely. Overcoming humanity's most stubborn technological barriers demands a departure from refining existing ideas. It requires abandoning the accepted model entirely to look beneath the surface. In the early 20th century, engineers faced a physical wall, catching an invisible, weightless electromagnetic wave and translating it into a signal a human being could actually understand. The initial answer relied on brute force. Early receivers forced these delicate waves to trigger physical clicks in heavy brass telegraph keys. But moving physical metal meant dealing with mechanical friction, and friction put severe limits on how fast a signal could be received. To strip away that physical weight, inventors turned to vacuum tubes. Devices like the Fleming valve replaced moving metal parts with streams of electrons flowing through an exhausted glass bulb. By passing currents through complex internal wire structures, engineers like Lee DeForest amplified those faint radio signals and built the foundation for modern electronics. Yet, even with these early glass tubes, the industry was still hunting for an ultra-sensitive, entirely frictionless way to detect the faintest high-speed signals. The speed of global communication was bottlenecked by the receiving hardware itself. The invisible waves traveling through the air were fast, but the physical components built to catch them couldn't keep up. In May of 1919, Nikola Tesla published an article in an engineering journal revealing a long-kept secret. 27 years earlier, in 1892, he had already designed a detector that abandoned traditional circuitry entirely. His design was a glass vacuum bulb, similar to the standard tubes of the era, but with a baffling physical anomaly. There was absolutely no wire leading to the inside of the glass. Tesla bypassed conventional electronics completely, creating a self-contained environment that reacted to external magnetic fields with immediate, visible movement. We know exactly how he built it because he detailed the construction step by step in the Electrical Experimenter magazine. The device starts with a primary outer glass envelope, which Tesla simply referred to as Globe L. Sealed directly into the neck of this outer globe is a thick glass barometer tube, pointing downward into the center. At the very tip of that inner tube is a paper-thin, tiny sphere. This delicate inner sphere is then filled with a specific conducting powder, acting as the energetic heart of the device. Notice the most critical engineering feature here. The vacuum chamber is entirely sealed, without a single metal wire piercing the main globe to connect the inside to the outside world. This electroless design deliberately broke the rules of closed-loop circuitry. By severing the physical electrical connection, Tesla created an isolated environment primed for a different kind of physical phenomenon. Once the bulb is highly exhausted of air, it requires no plug. Simply grasping the glass with your hand or connecting the neck to a high-frequency generator activates the internal gas. At first, the inside of the globe fills with a wide, diffuse, white misty light, but as the current continues, a crucial physical transition takes place. The diffuse mist dramatically condenses into a single sharp shaft of light. This newly formed light shaft is incredibly sensitive. If a person simply walks near it, or if a tiny horseshoe magnet is brought close, the beam violently deflects. This focused plasma needle reacted to microscopic magnetic disturbances that standard filaments couldn't even register. This plasma needle neatly bypassed the mechanical lag problem that plagued early telegraph receivers. Because the beam consists only of ionized gas, it carries absolutely zero mechanical weight and experiences zero friction. It reacts instantaneously to incoming high-speed radio signals. The beam snaps back and forth, dancing in perfect synchrony with remote dots and dashes. To extract the data, a human operator could either watch the dancing light directly, or, for ultra-fast transmissions, expose the light to a fast-moving strip of photographic film to record the rapid movements. By translating an invisible, weightless magnetic field directly into a visible, equally weightless medium, Tesla bypassed physical mechanics entirely. Ultimately, history took a different path. Lee DeForest's Audion tube was easier to mass-produce and commercialize. It won the industrial race and became the bedrock of modern electronics. But the electroless bulb remains a testament to Tesla's lateral thinking. In 1892, he was envisioning solutions utilizing plasma physics, decades before the rest of the world caught up. While it didn't build the modern radio industry, it remains a working proof of concept that electromagnetism can be translated directly into visible light without moving a single piece of metal. Standard engineering follows a rigid path. Sketch a design, build a physical prototype, and then iterate through repeated failures. It is a slow, expensive cycle of trial and error. Nikola Tesla bypassed this physical cycle entirely. When he developed the alternating current induction motor, a machine utilizing a rotating magnetic field for mechanical power, he did so without a single drafting phase. He constructed his machines within the confines of his own mind. He visualized the exact dimensions of every internal component, assembled them mentally, and set the device in motion in his imagination. He claimed that running a turbine in his thoughts yielded the same data as a physical shop test. He could even identify if a spinning part was slightly out of balance simply by watching it operate in his mind. This precision suggests a mind wired differently from birth. Was this a biological anomaly or a skill learned through necessity? To find the source of this mental laboratory, we have to look at a childhood defined by trauma and a sensory sensitivity so intense it forced him away from the physical world. Growing up in Smiljan, young Nikola was never the focal point of his family's expectations. His older brother was recognized as the true genius of the household, a child gifted to a degree that overshadowed Nikola's early efforts. That promise ended in tragedy. During a mountain trek, the family's horse was spooked by wolves and reared violently, throwing his brother to his death. Tesla witnessed the accident firsthand. The visual impression of the scene remained permanently etched in his memory, fueling vivid flashbacks for decades. In the wake of the funeral, Nikola's own achievements felt hollow to his grieving parents, serving only as a painful reminder of the son they had lost. His father then attempted to dictate his path, demanding he abandon engineering to become an Orthodox priest. Pressed by parental grief and an unwanted career, Nikola retreated inward, creating an internal world where he could survive the pressures of his reality. This inward retreat coincided with overwhelming biological quirks. Tesla experienced acute and often painful sensitivities in his sight and hearing. His hearing was so sharp that he could discern the faint crackling of distant fires before they were visible to anyone else. He also struggled with uncontrollable visual flashes. Hyper-realistic images and bursts of light would suddenly appear, obscuring his view of the physical world. These involuntary hallucinations often made it difficult to tell what was real, paralyzing his ability to function like a normal child. Tesla eventually learned to discipline these visions, forcing his imagination to create specific, controlled scenes to block out the chaotic flashes. He began consciously constructing functional mechanical systems in this space, replacing his early mental escapes with rigorous engineering. This mental engineering process emerged from a hypersensitive boy learning to harness and organize a chaotic sensory overload. By adulthood, Tesla had turned this survival mechanism into history's most efficient engineering tool. His imagined machines were mathematically accurate simulations. When he moved to physical construction, the devices worked exactly as they had in his mind. This stood in direct opposition to contemporaries like Thomas Edison. Thomas Edison relied on exhaustive physical trial and error, testing thousands of glass filaments until one of them finally stayed lit. Because his work was internal and invisible, critics labeled him a dreamer and questioned his sanity. They misunderstood his environment. Tesla was executing complex engineering in a mental landscape as real to him as physical reality. His physical successes proved the math was right. He built systems that generated deadly arcs of electricity across his lab, results born from flawless mental prototypes. Tesla's real laboratory existed within a mind forged by grief and sensory anomaly, a disciplined space where he could invent the future without ever needing a physical prototype. If you look up at the night sky, you will only ever see one face of the moon. The craters and dark patches visible tonight are the same ones humanity has looked at for thousands of years. This diagram shows the standard explanation: tidal locking. It's a phenomenon where an orbiting body's rotational period perfectly matches its orbital period. To keep one face pointing inward, the moon theoretically completes exactly one 360-degree spin on its axis every time it circles the Earth. Pick up any elementary physics textbook or visit any planetarium, and this synchronized spin is presented as a fact of our solar system. Our standard understanding of the moon's movement relies on this visual synchronization being proof of an actual physical spin. Nikola Tesla viewed this celestial phenomenon through the lens of a mechanical engineer. To him, the mainstream explanation was a mathematical impossibility. Tesla developed the alternating current induction motor by harnessing the rotating magnetic field. His mastery of rotational forces allowed him to design the power systems that define modern life. When Tesla analyzed the moon's movement, he declared its axial rotation a delusive appearance. He argued that what looked like a spin was actually a violation of physical law. Tesla wasn't debating the movement astronomers observed, he was questioning the physical cost of that movement. Tesla based his argument on a single metric, vis viva, the historical term for the kinetic energy of a mass in motion. In mechanics, any object spinning on its axis possesses rotational kinetic energy, a measurable quantity stored within its mass. The moon weighs roughly 2.4 quintillion tons. Tesla calculated the energy required to rotate that mass one full turn every 27 days. According to his math, that rotation would generate 1 billion horsepower, sustained for 1,323 years. Tesla found no evidence of this energy signature existing in space, concluding that the rotation itself cannot exist. Tesla used a geometric thought experiment to explain this illusion. As these balls revolve on spokes, they travel in a circle, keeping the same face toward the hub. They don't spin independently. They only possess translational energy. To make one of these balls physically rotate on its own axis during the revolution, you would have to apply a separate, measurable force to it. Tesla argued that gravity acts like these rigid spokes. The moon translates around the Earth, but it never initiates its own axial rotation. The confusion arises when we interpret this orbital translation as an independent energy-producing spin. Tesla proposed a final test to check for this stored energy. He asked what would happen if the pull of gravity were suddenly eliminated. Test this on Earth. If a spinning object on a string flies loose, it keeps rotating. The string snaps, but the stored rotational energy remains. Applying this to the moon, it should behave like a spinning top the moment it is released from Earth's pull. But Tesla's mechanics predicted the moon would fly off in a straight line, with no swerve or axial rotation. This lack of independent spin after the tether breaks would prove that the moon holds no rotational energy in its current state. Mainstream astrophysics continues to categorize tidal locking as a form of rotation, prioritizing the geometry of the orbit over mechanical objections. Tesla's methodology was different. He refused to accept a phenomenon simply because it looked a certain way. He treated celestial bodies as if they were industrial components, forcing them to obey the same tangible laws of engineering he used in his laboratory. This approach changes how we look at the night sky. It shifts the question from what we see to what the physics requires. Tesla's legacy suggests that true inquiry requires looking past appearances to find the hard mathematical proof of energy and motion. This archival photograph shows a bizarre 187-foot wooden tower with a massive 68-foot mushroom dome built on Long Island in 1901. This portrait shows its creator, Nikola Tesla. He was already famous for alternating current, the system that powers our homes today, but his peers frequently mocked him in the press as a dreamer or a madman. Tesla was simply operating with a mind that lived a full century ahead of its time. The Long Island structure served as the physical hardware for a global infrastructure project he called the World System. Wardenclyffe represented an analog version of a central internet server, conceived decades before the invention of the microchip. This 1919 magazine page details his world system. He proposed a receiver not bigger than a watch for global voice communications, alongside universal time syncing and compass-free marine navigation, the exact functional goals of our modern GPS satellite network. Without satellites, digital screens, or microchips to process data, the engineering question remains: how did he physically plan to connect the globe? The magnifying transmitter was his mechanical solution to a digital problem, a machine designed to bypass the atmosphere entirely. This is a portrait of Guglielmo Marconi. He championed the prevailing science of the era, which relied on what physicists call Hertzian waves. Hertzian waves work by radiating energy outward through the air in all directions, similar to ripples spreading across a pond. Tesla found this method inefficient. He argued that radiating energy out into space was as wasteful as trying to shout across an ocean. He believed global transmission through the air was physically flawed, requiring a complete departure from traditional radio physics. His radical shift in thinking was to avoid the air entirely and pump energy deep into the ground. He called this concept terrestrial stationary waves, electrical vibrations that remain anchored within a conductive medium rather than radiating away. During his experiments in Colorado Springs, he observed that the Earth itself acts as a massive, highly efficient conductor of electricity. This diagram shows his system. The magnifying transmitter acted as a colossal resonant transformer designed to pump millions of volts directly into the planet's crust. By pumping electricity into the ground at a precise frequency, Tesla believed the entire planet would ring like a tuning fork. Within this closed resonant system, energy is preserved in the Earth itself, allowing signals to travel worldwide without weakening. The magnifying transmitter essentially converted the entire planet into a colossal electrical wire. To access this global network, a user would carry a small, tuned pocket receiver and plant a metal pin directly into the dirt. This ground connection would theoretically allow the user to extract both communication data and physical electrical power from the resonating Earth. While Tesla successfully demonstrated that the Earth could carry these currents, the Long Island Tower lost its funding before completion as the world moved toward war. This painted illustration shows the utopian dream that never materialized. The tower was dismantled for scrap, and Tesla spent his final decades largely ignored by a world that could not yet utilize his vision. Economic pressure and the outbreak of war effectively ended the project, leaving Tesla's planetary physics untested on a global scale. Tesla's 1900 vision of a globally connected, wireless information-sharing world proved to be remarkably accurate. Today, we rely on the atmospheric radio waves he found inefficient, using cell towers and Wi-Fi to create the global connectivity he predicted over a century ago. The magnifying transmitter stands as the first physical blueprint for the information age, designed by an inventor who was already mentally residing in the 21st century. Every July 10th throughout the 1930s, the press corps gathered at the Hotel New Yorker for Nikola Tesla's birthday. The elderly inventor would hold court in his suite, offering reporters a glimpse into the mind that had already wired the entire globe. He spoke of technologies that defied the physics of the era. He detailed his plans for harvesting raw cosmic energy to run machinery, and described methods for transmitting communication signals to other planets. The reporters dutifully reported his quotes, but the tone of their articles was often dismissive. They framed him as a broken figure, the aging, mad scientist whose best engineering years were decades behind him. Yet those journalists only had to look out the hotel window to find the evidence they were missing. Down below, Times Square was ablaze with light. Streetcars drew immense power from the underground grid he had designed. His work was humming through the very walls of the room where they sat. Tesla's later claims were judged harshly because he was speaking a technological language of the future. The present simply lacked the tools to translate him. In the 1880s, the young Tesla was at the absolute peak of his mental capacity. He possessed a highly unusual psychological process for inventing. He could construct, test, and refine complex machinery entirely within his imagination. He ran turbines in his mind for weeks to check for mechanical wear, bypassing the need for physical prototypes entirely. His process differed from the famous methodology of Thomas Edison. Edison relied on exhaustive physical trial and error, often testing thousands of physical materials to find a working light bulb filament. Operating in this mental forge, Tesla conceived the concept of the rotating magnetic field. This schematic illustrates the physics of the discovery. By synchronizing alternating currents, electricity reversing direction multiple times per second, Tesla generated shifting magnetic lines of force. This created an invisible, whirling magnetic cyclone, pushing a central rotor continuously without mechanical contact. This invisible force, drafted entirely in his mind, became the foundational blueprint for the entire modern power grid. Moving from imagination to industry required capital, but Wall Street investors in the late 19th century struggled to finance a concept as abstract as an invisible magnetic field. To secure funding, Tesla engineered a demonstration called the Egg of Columbus. He applied alternating current to a coil-wrapped wooden ring, proving this invisible force could perform physical work. The magnetic field grabbed the copper egg, spinning it perfectly upright. By translating an abstract mental concept into a spinning piece of copper, he secured the financial backing necessary to launch his commercial career. His motor technology scaled to massive industrial proportions. Within a decade, his systems were deployed at Niagara Falls, harnessing the mechanical power of the cascading water for the first time. Having conquered conventional power generation, he began experimenting with extreme high-voltage energy. He utilized his newly invented Tesla coil, a transformer circuit designed to produce high-frequency electrical discharges. This led to his work at a laboratory in Colorado Springs, where he successfully generated 100-foot bolts of man-made lightning. By the turn of the century, Tesla had demonstrated a consistent ability to pull these massive high-voltage phenomena out of his mental calculations and into the physical world. This work culminated in his most audacious project, the magnifying transmitter at Wardenclyffe on Long Island. Tesla's vision for wireless energy relied on a concept he called earth resonance, an approach that used the ground itself rather than the air to transmit power. This diagram illustrates his mechanics. Instead of broadcasting signals through the atmosphere, he intended to pump massive electrical oscillations directly into the Earth's crust. He treated the entire planet as a giant ringing conductor. His goal was universal access. Anyone on the globe could theoretically tap into limitless industrial power simply by driving a receiver stake into the ground. The Wardenclyffe project eventually collapsed. The planetary scale of a project that offered free, unmetered energy proved impossible for his commercial backers to support, and his funding was withdrawn. The physical destruction of the tower marked a turning point. It was the moment the public stopped following his vision and began categorizing him as an eccentric dreamer. This leads back to that hotel room in the 1930s, and the 82-year-old Tesla describing his latest findings to a room full of scoffers. When a single mind builds the electrical foundation of modern civilization purely from imagination, his later claims deserve a closer read. He was describing an engineering reality the rest of the world has simply not yet reached. By the late 19th century, cities were racing to electrify, but they hit a hard physical limit. The existing direct current power grids could only push electricity a few miles before the voltage dropped off completely, requiring power plants on nearly every city block. Engineers knew that alternating current, or AC, was the theoretical solution. It could travel hundreds of miles with ease, but the top minds of the era considered it useless for industrial work. The roadblock was mechanical. Because alternating current constantly reverses direction, feeding it into a motor resulted in chaotic pushing and pulling forces. The opposing magnetic fields fought each other, locking the machinery instead of producing continuous rotation. The stakes were absolute. The first person to crack the alternating current motor problem would command limitless industrial power and dictate the energy infrastructure of the globe. Nikola Tesla spent 5 years obsessively focused on this exact mechanical deadlock. He approached the problem unlike any other engineer. Instead of building physical prototypes and testing them through trial and error, Tesla claimed to have solved the entire system solely in his imagination. Within his mind, he mapped out a physics concept he called the rotating magnetic field. But an abstract physics simulation in an inventor's head has no market value. To build it, he needed capital, which meant pitching his theoretical math to Wall Street financiers. This created an immediate conflict. Tesla had to prove the existence of an invisible theoretical magnetic cyclone to businessmen who only trusted physical, tangible results. To bridge that gap, Tesla brought a group of potential investors into a room centered around a peculiar circular wooden platform. He started by challenging the men with an old riddle. He asked if they could make an egg stand perfectly upright on its pointed end without cracking the shell. When they couldn't, Tesla placed a solid copper egg onto the center of the wooden board. He then reached over and threw a heavy electrical switch to energize a machine hidden beneath the table. Instantly, the heavy copper egg began to spin at a furious rate. As it gathered speed, it rose up and stood perfectly upright on its point. He escalated the demonstration. Tesla threw additional brass balls and pivoted metal discs onto the platform. The moment they hit the wood, they began spinning rapidly, migrating outward to orbit the upright central egg like a miniature planetary system. The demonstration physically manifested Tesla's mental blueprint, proving to the investors that an invisible, highly organized rotational force was dominating the space above the table. The secret lay entirely beneath the wooden board. A standard 19th century electromagnet simply generates stationary lines of force. When you turn it on, it attracts a piece of iron and holds it fast in a static grip. Tesla bypassed this static grip by feeding two-phase alternating current into his coils. Two-phase current is a system that delivers two separate waves of electricity that peak at slightly different times. He routed these overlapping waves in a precise mathematical sequence, forcing the four coils to reach maximum power one after the other. By sequentially pulsing those stationary coils, the magnetic lines of force above them formed a continuous whirling vortex. The copper egg was caught in this invisible cyclone and forced to spin in synchronization with the moving field. This rotating magnetic field acted as a frictionless, gearless transmission. It finally allowed alternating current to generate smooth, continuous mechanical power. The investors had seen enough. Stunned by the physical proof, they provided the capital to form the Tesla Electric Company in 1887. With a dedicated laboratory, Tesla immediately began constructing his first physical induction motors. Because he had perfectly simulated the rotating field in his mind for half a decade, the very first physical motors he built worked exactly as he had envisioned, without requiring a single experimental modification. That specific machine successfully bridged the gap. It took a theoretical physics demonstration and turned it into a viable industrial product. The motor's success allowed George Westinghouse to secure an arrangement to manufacture Tesla's design on a massive industrial scale. However, integrating the technology into existing infrastructure created immediate engineering friction. Westinghouse had already built his AC grids to operate at 133 cycles, meaning the current reversed direction 133 times per second. Tesla's motor, meanwhile, was optimized for a much lower frequency. Tesla had to concentrate his efforts on adapting his motor design to operate efficiently at this higher frequency and run on a standard two-wire system. Despite these infrastructural growing pains, the foundational physics held up. The rotating magnetic field had permanently solved the mechanical bottleneck of the alternating current system. Those early 200 horsepower laboratory experiments laid the exact groundwork for modern industry. Today, 15,000 horsepower motors apply the exact same principle to drive massive steel mills, propel ocean-going ships, and power electrified subway systems around the world. Every one of these modern mechanical titans traces its lineage directly back to the elegant physics of that first induction motor. Over 90% of the entire modern electrical industry relies daily on the invisible magnetic cyclone that Nikola Tesla first spun entirely within his own mind. Modern global communication operates on a principle that seems obvious: invisible waves beaming through the sky and ricocheting off the upper atmosphere to reach the other side of the planet. But in May 1919, a jarring article by Nikola Tesla appeared in the Electrical Experimenter, declaring this entire scientific consensus to be a total illusion. Tesla held the highest possible credibility at this moment. He was the undisputed genius who invented the alternating current system that powers the world. Tesla attacked the very foundation of radio, Heinrich Hertz's theory that electromagnetic waves fly through an invisible ether in the air. He argued that real Hertzian waves are blotted out after traveling only a short distance, rendering them mathematically useless for global communication. Yet by 1919, wireless messages were successfully crossing the Atlantic every day. The signals were clearly getting through. If radio waves aren't flying through the air as the entire world believes, we have to look at the father of wireless and his radical theory of how the universe actually works. Tesla saw a fundamental mechanical flaw in the standard radio model, radiating energy outward in 360 degrees into empty space. Because this radiation is spherical, energy dissipates so rapidly that reaching a distant receiver on the other side of the globe becomes impossible. Measuring high energy at the sending antenna is a useless metric, if only an infinitesimal fraction of that power survives the journey through the atmosphere. Tesla abandoned the theory of the sky entirely, and instead moved his focus straight down into the dirt. He proposed that the Earth itself, not the air, is the ultimate low-resistance conductor. In his true wireless methodology, you don't radiate energy into the void of space. You inject electrical impulses directly into the planetary crust. In Tesla's mind, a wireless receiver isn't catching a wave falling from the sky. It is feeling a localized, artificial electrical earthquake vibrating up through the ground. Tesla based these claims on massive-scale empirical tests he conducted in Colorado Springs in 1899. Those experiments proved to him that he could create resonant electrical frequencies within the Earth itself. To exploit this resonance, he invented the magnifying transmitter, a peculiar transformer specifically adapted to excite the Earth. The machine operates like a massive pump disturbing water in a closed system, creating rhythmic electrical pressure waves. His goal wasn't just a simple telegraph signal. He wanted to vibrate the entire electrical capacity of the globe at once. If Tesla's experiments worked, why don't our cell phones and radios use this earth-pumping system today? While Tesla was testing the crust, his commercial competitors realized that airborne waves were perfectly sufficient for carrying low-energy information like voice and code. Tesla ignored the communications market because he was solely focused on the transmission of massive amounts of industrial power. He made a staggering promise to the world: the ability to safely transmit enough energy through the ground to light 200 incandescent lamps across the globe with 0 wires. He began building Wardenclyffe Tower as the first node of a global grid, envisioning airships and cities drawing power wirelessly from the ground. The 1919 True Wireless article serves as the theoretical bedrock for Tesla's ultimate unfulfilled dream of a completely interconnected, globally powered utopia.
A moment of wonder. When 1,000,000 volts of electricity rip through the air, the sheer violence of the discharge captures our immediate attention. But the real story of this machine starts in the late 1880s, when engineers raced to harness high-frequency alternating current, a type of electrical flow that reverses direction periodically, for industrial power. The earliest generators forced a heavy iron armature to spin inside a magnetic field. To generate a higher electrical frequency, engineers had to physically spin that metal faster. Physics sets a hard limit on spinning heavy metal. Push an armature past a few thousand revolutions per minute, and centrifugal force tears the machine to pieces. Other scientists experimented with spark gap circuits, known as Hertzian setups, named after physicist Heinrich Hertz. But these generated highly damped waves, energy pulses that faded out almost immediately, rendering them useless for large-scale power transmission. Nikola Tesla looked at this hardware and realized mechanical velocity was a dead end. Instead of fighting physical mass, he needed to exploit the invisible physics of resonance. He needed a system that could take a standard, low-frequency electrical supply and chop it into a steady, perfectly timed stream of high-frequency pulses. By abandoning moving iron parts entirely and relying instead on tuned electrical circuits, Tesla built the electrical oscillator. To understand how Tesla's oscillation transformer works, we must look at fluid dynamics. High-frequency electricity behaves remarkably like a pressurized fluid moving through pipes. This technical diagram from Tesla's own notes shows a mechanical analog to his circuit. A reciprocating pump forces fluid into a cylinder, pushing against a spring-loaded piston. In the electrical version, a generator pushes current into a capacitor, a device that stores electrical charge, building up immense electrical pressure, or voltage. When that pressure overcomes the spring, the ports open and the fluid bursts out, causing the system to quiver at its own natural rate. Electrically, when the voltage jumps across an air gap, it releases the stored energy in a long series of isochronous impulses, waves that vibrate at a perfectly constant period. The massive sparks produced by the oscillator are simply the result of a mechanism storing energy slowly and releasing it with mathematically precise timing. The pulses from that first circuit, the primary, are only half the system. Tesla placed a secondary coil nearby, physically disconnected but magnetically linked to the first. He carefully calculated the wire length and capacity of this second coil, so it shared the exact same natural vibrating frequency as the primary circuit, a process known as tuning. This diagram illustrates the relationship between the two circuits. The steady pulses of the primary wave push the secondary wave, and because their timing is identical, every small push adds to the previous one, causing the voltage in the secondary circuit to multiply. This synchronized rhythm bridges the gap between the coils. Energy transfers through the air from one circuit to the other, reaching conversion efficiencies as high as 85%.
By discarding spinning metal armatures in favor of precise electrical timing, Tesla found a way to multiply energy far beyond the limits of brute mechanical force. Tesla eventually scaled this exact principle up to the size of a building. He designed the magnifying transmitter, a massive facility at Wardenclyffe in New York, intended to serve as the engine of a global wireless network. Instead of broadcasting radio signals out into the void of space where they quickly dissipate, he proposed treating the Earth itself as a giant spherical conductor. This schematic shows the setup. By grounding his massive oscillator, he intended to pump the planet's electrical field, forcing the globe to quiver at a specific pitch. In Figure 10, distant receiving circuits are tuned to that same frequency to tap into that energy anywhere. The Wardenclyffe Tower was demolished before the world wireless system could be completed. However, the electrical oscillator he designed to power it became the foundational technology for early radio transmitters, for X-ray generation, and modern high-voltage engineering. Mention Nikola Tesla today, and the image that comes to mind is almost pure mythology, a reclusive mad scientist surrounded by sparking coils, living entirely in the clouds of his own imagination. But the historical reality is far more grounded. In 1919, prominent science journalist Hugo Gernsback sat right across a desk from the actual man. Gernsback deliberately ranked Tesla's genius above household names like Thomas Edison and Michael Faraday, citing a track record of over 75 original discoveries. To understand the electrical world we live in today, we must strip away the pop culture caricature and look closely at the man Gernsback actually met. When the door opened, Gernsback was greeted by a stately, gaunt figure standing well over 6 feet tall. The physical contrast was immediate. He offered a surprisingly powerful handshake, punctuated by a fast-paced, high-pitched voice. Gernsback immediately noted his deep-set blue eyes, a long, scientific nose, and a distinct, pronounced bulge on his high forehead. In Gernsback's assessment, this cranial structure was the definitive physical marker of exceptional intelligence. Tesla's sharp physical precision flatly contradicted the public's image of a frail, disconnected dreamer lost in his own mind. Tesla's intellect functioned as a high-capacity mental framework, a disciplined operating system that processed information with mechanical precision. He consumed information voraciously, utilizing a photographic memory to recite entire volumes of Shakespeare and Goethe by heart. That mental capacity extended to linguistics, enabling him to speak and write fluently in 12 different languages. He held absolute contempt for the standard engineering slide rule, executing complex mathematical calculations entirely in his head before ever touching a physical prototype. His genius was the product of this rigorous mental infrastructure, far removed from random flashes of creative inspiration. Tesla maintained his physical body with the same intense discipline, utilizing a gastronomical frugality to sustain high energy and youth into his 60s. He believed most people eat themselves to an early death, so he engineered his own savory, optimized meals to specifically fuel his work. He strictly eliminated tobacco and black coffee to protect his physical machinery from any interference. This internal control mirrored his external independence. When Kaiser Wilhelm of Germany sent Tesla a personal invitation to the royal palace, the inventor simply ignored it. Tesla forgot the first request and later set aside 2 more renewals, completely unmoved by the promise of unprecedented royal honors. He maintained absolute sovereignty over his time, beholden to no habit and no global monarch. Despite being so disciplined and prolific, Tesla died in relative obscurity compared to contemporaries like Thomas Edison. Gernsback identified the problem. Tesla actively refused to employ a press agent and hated the public relations game. His breakthroughs, like high-tension current transmission and the rotating magnetic field, were also highly technical and abstract, making them difficult for the average public to grasp. Despite his reputation as a dreamer, Tesla earned over $1 million from his patents, but he immediately spent every cent to fund his next generation of research. Tesla deliberately prioritized scientific truth and global progress over personal wealth or the pursuit of popularity. We see his ultimate legacy in testing the absolute limits of nature, often sitting calmly reading a book beneath millions of volts of artificial lightning. Tesla spoke a language of physics and energy that the rest of the world would take decades to decipher. Gernsback viewed him as an idealist of the highest order, whose only real crime was living a full century ahead of his time. If you look up at the night sky, you will only ever see one side of the moon. This diagram illustrates the standard astronomical model known as synchronous rotation, or tidal locking. It shows how the moon completes exactly one full rotation on its axis in the exact same time it takes to orbit the Earth once. Orbital mechanics teaches this dual motion, orbiting while spinning, as a basic undisputed law of the solar system. Because this geometry perfectly predicts what we observe from our backyards, astronomers rarely stop to ask if that mathematical spin is driven by an actual physical force. Enter Nikola Tesla. By 1919, he was universally recognized as a titan of mechanical engineering and the architect of the alternating current motor. But that same year, he published a fiery article in the Electrical Experimenter magazine, declaring the moon's axial rotation to be a famous scientific illusion. His claim was absolute. He argued that the moon does not rotate on its axis even a fraction of a degree. He believed it is entirely devoid of internal spin. How could the man who invented the rotating magnetic field fail to grasp the basic geometry of the Earth and its satellite? Either the world's most famous inventor had lost his grip on reality, or the scientific community's definition of rotation was hiding a massive conceptual flaw. If that entire solid mass is turning, the moon itself isn't spinning on its own independent axis. It is simply a fixed point being carried along by the larger structure. To human eyes looking up from the center, simple translation through space looks identical to a self-driven spin. Tesla decided to strip away the visual geometry entirely and subject the moon to a strict mechanical test. He argued that true rotation requires energy of motion. In physics, translational energy is the force of an object moving forward through space. Rotational kinetic energy, or vis viva, is the specific, measurable energy stored inside an object when it spins on its own axis. Tesla calculated that if a mass as large as the moon were actually spinning, it would generate over 11 trillion short foot-tons of rotational energy, but his math showed the moon contains zero rotational momentum. He noted it didn't even possess enough internal energy to run a delicate watch. To a mechanical engineer, physical motion without measurable kinetic energy is an absolute impossibility. To Tesla, the astronomer's spin was nothing more than a mathematical fiction. To finally isolate the moon's energy, Tesla devised a scenario testing what would happen if Earth's gravity suddenly vanished. If you whirl a ball on a string and the string breaks, the ball flies outward and spins rapidly, releasing its stored rotational momentum. This technical diagram illustrates Tesla's countermodel. The moon mechanically mimics a ball fixed rigidly to a solid rotating spoke. If that spoke snaps, the moon flies off in a straight tangent line, maintaining a completely fixed orientation without any internal rotation. By mathematically removing the Earth, the thought experiment strips the system down to its raw mechanics. It proves that a synchronous orbit provides absolutely zero independent rotational momentum to the celestial body itself. So, who is actually right here? The mainstream astronomers or Nikola Tesla? This split-screen diagram shows the astronomer's perspective. When plotted against a fixed grid of distant stars, known as a stellar reference frame, the moon does indeed complete a full 360-degree rotation during its orbit. But Tesla flatly refused to accept relative geometry as a substitute for absolute, measurable mechanical energy. The disagreement centers on the definition of rotation itself, specifically whether it describes a geometric path or an internal state of energy. Tesla's hyper-mechanical view of the universe demanded that every single movement be accounted for in raw, tangible, measurable energy. That exact, rigid, absolute mindset is what gave him the unique ability to visualize complex machines in his head and invent the modern electrical power grid. Exploring Tesla's highly unorthodox theories forces us to look past simple textbook geometry, pushing us to understand the physics of our universe with rigorous precision. If you want to invent something new, the universally accepted process goes like this. You generate a rough idea, you build a crude prototype, you find out where it breaks, you fix the flaws, and you repeat the cycle until it works. The most famous champion of this brute force method was the inventor Thomas Edison. He lived by physical trial and error. He would sit in his laboratory, surrounded by glass, chemicals, and wire, engaging in endless physical tweaking. Modern hardware and software companies still rely entirely on this philosophy of rapid physical iteration. But the moment you start building, physical constraints take over. You spend your time fighting friction, material defects, and manufacturing delays instead of perfecting the core concept. The budget drains, energy is wasted, and months evaporate before you even know if the idea is sound. Nikola Tesla claimed something almost impossible to believe. For 20 straight years, he never built a single physical prototype. He bypassed the workbench completely. During his design phase, he didn't use slide rules, ignored technical textbooks, and absolutely refused to construct preliminary models. Yet when he finally constructed his alternating current generators, massive, highly complex machines that would go on to electrify the globe, they operated exactly as planned the very first time they were physically switched on. Tesla didn't skip the prototyping phase. He bypassed physical limitations by building a flawless, zero-friction physics simulator entirely inside his own mind. This capability was born from trauma. As a child, Tesla suffered from a severe psychological affliction. He was plagued by blinding flashes of light that would suddenly fill his vision, accompanied by overwhelming, uncontrollable hallucinations. To survive the sensory overload, he treated his mental control as a matter of psychological survival. He developed extreme willpower to forcibly banish these visions from his mind. Over time, he moved from defense to offense. He began intentionally summoning specific, controllable images, eventually building a vast mental sandbox where he dictated every detail. By conquering a debilitating psychological burden, Tesla inadvertently forged the most precise, disciplined, inventive mind in human history. We can see exactly how he used this by looking at his greatest conceptual breakthrough, the rotating magnetic field. This is the engineering principle that allows alternating current to spin a motor using magnetic forces instead of physical mechanical contacts. Step 1 of his process was total concept visualization. When the initial idea hit him, he detached entirely from the physical world. He refused to rush to the workbench to test it. Step 2, the stress test. He would conceptually turn on the machine in his mind's eye to see how the invisible forces interacted. He tracked the alternating currents, checked the rotor for imbalances, and simulated long-term wear and tear to see where friction would break it down. Step 3 was execution. He had one strict rule. He only committed the design to paper and metal when the mental simulation moved with the exact efficiency and mechanical equilibrium he required. This is the historic physical model of his first induction motor, born exactly as he imagined it. By iterating without physical constraints, Tesla resolved every engineering conflict before he ever turned a single screw. That level of absolute certainty is critical when securing capital from highly skeptical Wall Street investors. A standard inventor would show up to a pitch with a crude, half-working physical prototype, tweaking it nervously on the table to beg for money. Tesla confidently set up a polished wooden table with a rotating magnetic field hidden underneath. He placed a copper-plated egg on the surface and made it spin until it rose to stand perfectly upright on its point. This mental preparation transformed a technical demonstration into a psychological victory, securing the capital and belief needed to bring the invention to life. Tesla was a rare genius, but the mechanics of his extreme mental discipline can be adopted by anyone facing a complex problem. You do not need to be engineering a high-frequency alternator to apply this method today. If you are an entrepreneur, a software developer, or a writer, you have to mentally stress test your business models, your code architecture, or your narrative structures. You have to locate the logical breaking points before you type a single word. We often rush to the physical execution phase, writing the draft, opening the CAD software, building the app, because the simple act of building makes us feel productive. But stop rushing. True creation and problem-solving do not happen on the workbench or the keyboard. They happen in the disciplined, limitless. Look around the world today, and you will find a massive network of data and power pulsing through the air. But in the late 1880s, electricity was strictly bound to heavy copper wires and massive steam engines. Engineers of the era faced a specific theoretical challenge: In 1856, the physicist Lord Kelvin proposed a mathematical theory for condenser discharges, a method to release stored electrical energy in rapid, high-frequency bursts. However, translating the math into a working machine remained a practical obstacle. Enter Nikola Tesla. Unlike inventors who tinkered through trial and error, Tesla lived intensely inside his own mind. He constructed and tested machines in his imagination long before he ever picked up a wrench. Tesla focused on mastering these high-frequency oscillations. He realized the standard technology of the day, heavy transformers built with solid iron cores, would fail. The iron could not handle rapid magnetic changes without overheating. Overcoming this physical limitation was the required key to unlocking wireless technology. Without a new architecture, radio waves would remain a laboratory curiosity. In 1891, inside his Grand Street laboratory in New York, Tesla set out to translate his mental model into a physical machine. This schematic shows what he built: the oscillation transformer, better known today as the Tesla coil. By removing the iron core, he created a circuit using just open air, a primary copper coil, a secondary coil, a spark gap, and a condenser, an early term for a capacitor, which is a device used to store electrical charge. The secret was electrical resonance. Energy bounces back and forth between the condenser and the coil. Each pass amplifies the frequency, much like pushing a child on a swing at the exact right moment builds their height with every oscillation. This 8-inch high prototype generated 5-inch electrical sparks, a demonstration that proved the efficiency of his air core design. While the public saw a spectacular scientific trick, Tesla looked at those sparks and saw a proof of concept for a technology with broad scalability. To push the limits of resonance, Tesla required vast open space and specific atmospheric conditions. In 1899, he relocated his experiments to the high-altitude plains of Colorado Springs. Here, he transitioned from building lab instruments to constructing a dedicated experimental station. Looking at this scale comparison reveals the size of the new machine. While his original New York primary coil was measured in inches, the Colorado Springs version spanned 51 feet in diameter. This 51-foot base drove a central secondary coil that could output millions of volts directly into the atmosphere. The results were thundering 100-foot disruptive discharges that could be heard for miles, the nearest approach to natural lightning ever generated by human hands. By scaling up his original mental model, Tesla had successfully engineered a machine capable of altering the Earth's localized electrical field. Tesla engineered these lightning bolts for a specific function. He intended to use this technology to excite the Earth itself. This led to his most ambitious design, the magnifying transmitter, physically realized as the Wardenclyffe Tower on Long Island. He designed it to send power and communication wirelessly across the globe. This illustrates how the tower was intended to function. Instead of radiating radio waves into the air, the tower was designed to pump resonating electrical energy straight into the ground, propagating waves through the Earth's crust. Tesla's tabletop invention had evolved into a blueprint for a global machine, one designed to turn the entire planet into a single electrical conductor. Tesla's vision of worldwide wireless power eventually collapsed. Funding for the project dried up, and the Wardenclyffe Tower was dismantled and sold for scrap. Yet his core invention survived. The tuned circuits and resonant principles of the Tesla coil became the base architecture for early wireless telegraphy, X-ray machines, and the radio industry. Standing beneath his 100-foot bolts of man-made lightning in Colorado, Tesla looked back at the first tiny spark in his New York lab, a final proof that his original architecture remained efficient as its dimensions grew to meet the scale of the globe itself. A solid copper egg sits on a wooden table. Suddenly, without anyone touching it, it stands upright on its pointed end and begins spinning so fast it blurs. It completely defies gravity. The man who built this device was a young Nikola Tesla in the late 19th century. At the time, he carried the complete revolutionary design for the alternating current motor, a completely new way of transmitting power, entirely in his head. But brilliant equations do not build factories. For that, you need capital. And the financial establishment in New York was fiercely loyal to direct current, or DC. an older electrical system where power flows continuously in a single, unchanging direction. Tesla found himself in a tense meeting with a group of hardened New York businessmen and a witty, skeptical lawyer. They listened to his ideas, then dismissed his alternating current concepts as impossible perpetual motion schemes. Tesla's success now depended on his ability to sell his vision. He had to find a way to prove his invisible mathematics to a group of non-experts. Right in the middle of the pitch, Tesla pivoted. He asked the wealthy investors sitting across from him if they knew the famous legend of Christopher Columbus balancing an egg by crushing its bottom. When they nodded, Tesla proposed a wager. He told the room he could make an egg stand perfectly upright on its pointed end without putting a single crack in the shell. The investors were amused. The lawyer told Tesla that if he could outdo Christopher Columbus, they would pull a few ducats from their buckskins and fund his laboratory. Tesla stopped trying to pitch complex mathematics. By posing a riddle, he created a narrative vacuum, a challenge so intriguing that these practical, conservative men simply had to see how it ended. The very next day, Tesla brought the investors to his workspace. He presented a simple wooden table and a heavy copper-plated egg and invited the skeptics to gather around. He threw a switch. To the absolute astonishment of the room, the heavy copper egg spun violently, standing upright on its tip. The secret to the trick was hidden directly underneath the wooden tabletop. Tesla had built a two-phase circular iron core wrapped in heavy wire windings. This diagram shows how the standard DC electromagnet of the era worked. It created stationary lines of force that attracted a piece of iron and held it completely fast in a static grip. Tesla bypassed brute physical force entirely. He manipulated the invisible architecture of electromagnetism to move an object without touching it. By using alternating current, Tesla created a magnetic cyclone. The rhythm caused magnetic lines to continuously whirl. As this rotating field passes through the copper egg, it induces secondary currents inside. The egg's own magnetic field pushes against the rotation, forcing it to spin. Tesla actually left a warning in his notes for anyone trying this experiment. You must drain the egg first. The induced electrical currents generate so much intense heat that a solid, completely sealed egg will violently explode. This demonstration provided the physical proof for Tesla's polyphase AC theories. By combining two alternating currents, he created a steady, rotating flow of power. The investors lost their skepticism instantly. Before the meeting even adjourned, they wrote Tesla a substantial check to continue his work. The entire apparatus, from the wooden table to the concealed copper wiring, functioned as a working AC induction motor. This diagram shows exactly how the components map to modern engineering. The spinning copper egg served as the motor's rotor, the central moving part. The hidden coils acting upon it were the stator, the stationary housing that generates the field. The businessmen had unknowingly watched a fully functioning, miniaturized prototype of the future operate flawlessly. With the funding secured, Tesla's alternating current induction motors went into mass production, bypassing the distance limitations of the old DC power grids. These new motors scaled up rapidly. They powered heavy factories, electrified huge stretches of rail lines, and drove the deep infrastructure of rapidly growing cities. Today, these exact induction motors provide the mechanical power for modern global industry. Tesla's ability to apply a scientific spin to a 400-year-old myth secured the funding for the electrical motors that power the modern world. By the late 19th century, the battle to wire the world for basic electrical power had largely been won using alternating current. But physicists were already looking past lighting cities and toward a new invisible frontier, the study of electromagnetic waves. Exploring these waves required specialized tools, standard 60 cycles used for household power. Nikola Tesla initially tried to solve this problem using the technology of the day. He set out to build a physical, mechanical generator pushed to the absolute limits of endurance. This diagram shows the alternator of 10,000 cycles per second that Tesla constructed in 1891. It featured a massive metal armature with 384 distinct magnetic poles, spun by physical belts to achieve a staggering rate of rotation. The machine worked, but it was a dead end. Relying on heavy, rapidly spinning metal components revealed a physical barrier that stood between engineers and the high frequencies required for wireless technology. You simply cannot spin a heavy iron and copper rotor fast enough to hit millions of cycles per second. Long before you reach those extreme speeds, mechanical friction and centrifugal force will literally tear the machine apart. Even at safer speeds, the slight variations caused by mechanical friction mean the rotation is never perfectly constant. This ruins the production of perfect sine waves, the smooth, continuous oscillations that are absolutely necessary to achieve electromagnetic resonance. To reach the extreme frequencies needed for advanced research, electricity generation had to be completely decoupled from physical moving parts. Tesla realized he had to abandon the standard blueprint of a generator. Instead of relying on gears, belts, and spinning magnets, he looked for a way to create high-frequency oscillations using nothing but the physics of the electrical current itself. Tesla shifted his focus to a different electrical component entirely, a move he later described as a happy inspiration. In 1853, the physicist Lord Kelvin had published a theory detailing the mechanics of condenser discharge. A condenser, now commonly called a capacitor, is a passive electronic component that stores energy in an electrostatic field. While Kelvin outlined the math showing how a condenser could release energy in rapid bursts, it was Tesla who recognized how this could be engineered into a practical, motionless electrical engine. High-frequency generation was no longer a mechanical problem of gears and friction. It was now an electrical problem of capacities and currents. Tesla's solution was the oscillation transformer, now known universally as the Tesla coil. This diagram shows an 1893 mechanical analog drawn by Tesla, illustrating how invisible electrical currents behave like water flowing through a hydraulic system. On the left side of the diagram, an electrical source acts like a reciprocating pump. It constantly pushes fluid into a restricted tank, representing the condenser, building up intense pressure. That pressure continues to mount until it reaches a critical, predetermined limit. At that exact moment, the force pushes past the spring-loaded mechanism in the center, simulating electrical energy violently bridging an air gap. The accumulated energy then rushes into the system on the right side. Bouncing against the elastic walls of this secondary circuit, the flow creates a rapid, self-sustaining series of timed impulses. This schematic illustrates the exact same process mapped to actual electrical components. The generator charges the condenser, the built-up tension arcs across the spark gap, and the resulting current oscillates through the primary coil at high frequency. Tesla refined this discharge mechanism over years. He replaced simple air gaps with carbon arcs, tested quenched gaps in sealed atmospheres of argon and hydrogen, and even experimented with fine streams of conducting fluid. By tuning these circuits, static electrical pressure was converted into high-frequency kinetic vibration, achieving massive frequencies without a single spinning rotor. The immediate result of this solid-state generator was the ability to step up electrical currents to extreme volumes and pressures, far exceeding anything previously recorded. In later laboratories, Tesla used oscillation transformers to produce artificial lightning bolts spanning over 100 feet, with millions of volts arcing across the room. These massive discharges proved definitively that the physical limits of standard dynamos had been bypassed. By mastering high-voltage, high-frequency currents, Tesla acquired the exact toolset required to push energy and information through the air and earth over vast distances. The resonant action at the core of the oscillation transformer led directly to the development of tuned electrical circuits. A tuned circuit allows a receiver to isolate and amplify one specific frequency while ignoring all others. These circuits became the physical foundation for the first radio transmitters and early X-ray generating equipment. Tesla's ultimate vision for this resonant technology was the magnifying transmitter, designed specifically to pulse electrical energy through the Earth itself. Today, every wireless communication network, from car radios to modern smartphones, relies on the fundamental principle of frequency generation he perfected. By finally breaking the physical limits of mechanical rotation, Tesla engineered the high-frequency heartbeat of the modern world. In 1919, a web of copper and steel was remapping the American city. Horse-drawn carriages were losing ground to the electric streetcar. The technology driving those cars, and the industrial motors in the factories nearby, was alternating current. AC is a system of electricity that periodically reverses direction, allowing power to be pushed across massive distances. It was a system engineered by Nikola Tesla. But at the time, the public looked to other names. If you asked a passenger on that streetcar to name a great inventor, they would point to the fame of Thomas Edison. The man who designed the mathematical foundations of the modern grid remained a ghost to the people using his inventions every hour of the day. Tesla's work was difficult to track because his greatest contributions were entirely intangible. A glowing light bulb is a physical object the public can see and hold. High-frequency electromagnetic waves radiating through the Earth are much harder to conceptualize. Because Tesla spoke a scientific language decades ahead of his peers, the press of his day dismissed him as a dreamer who drifted away from practical science. Publisher Hugo Gernsback identified the problem. Tesla had committed the unpardonable crime of not having a press agent to explain his work to the world. Without a way to explain his invisible ideas to a non-scientific audience, Tesla's role in history was beginning to fade. Hugo Gernsback operated the Electrical Experimenter. It was a magazine with a circulation of over 100,000 science-minded amateurs, providing a direct line to the next generation of engineers. In the January 1919 issue, Gernsback published an editorial that challenged the entire scientific hierarchy. He claimed that Tesla was the greatest inventor in history, placing him ahead of Archimedes, Faraday, and Edison. To prove it, Gernsback announced an exclusive media event. Tesla would write his own autobiography, My Inventions, appearing as a monthly series in the magazine. It was a high-stakes attempt to rescue Tesla's reputation before he was written out of the 20th century entirely. The project started as a defense. Gernsback recounted a debate with a skeptical journalist who was astonished that anyone would rank Tesla above the world's more famous inventors. Gernsback argued that Tesla was like Moses, a man with brilliant revelations who was heavy of tongue and unable to make himself understood by the masses. The electrical experimenter would act as Aaron, the brother who translates complex, visionary messages into a language the public can follow. For the first time, Tesla was forced to document his internal world, explaining how he visualized entire machines in his mind with mathematical precision before a single part was cast. By providing this translation, Gernsback ensured that Tesla's concepts were finally readable by the society that already depended on them. The partnership produced striking visual results, like the iconic 1919 cover showing Tesla demonstrating a vacuum bulb that glowed without any wire connections. Inside, readers saw photos of Tesla sitting calmly in his Colorado laboratory while his massive coil filled the room with artificial lightning discharges 100 feet long. The series also documented his radical physics. In The True Wireless, Tesla disputed the standard theories of radio waves, arguing instead that signals were propagated as impulses through the Earth itself. Gernsback's team visualized his ultimate dream, the magnifying transmitter at Wardenclyffe, a system designed to beam industrial power across the globe using the planet as a conductor. By printing these concepts with clear, dramatic illustrations, the magazine anchored Tesla's abstract ideas in reality. The dreamer was now a documented pioneer. This editorial campaign created the definitive record of Tesla's life. The series Gernsback published remains the primary source for understanding how the inventor actually thought. The theories Tesla struggled to explain in 1919, global wireless networks and the remote control of machines, now form the backbone of our modern infrastructure. Tesla's math was operating in a future century. Gernsback's magazine gave that future a physical form that the public of the present could finally recognize. While the machines hummed in the background of the 20th century, the electrical experimenter ensured that the name of their architect stayed on the front page.